our channel. So in this session, let us have a look on difference between the structures and unions. So as we have discussed in the structures, a structure is defined as a group of elements with different data types, and the union definition is also same. So union is also defined as a group of elements with different data types. So the only difference between the structure and the union are the memory location. So how the memory is allocated for the structure variable and how the memory is allocated for the union variable. That's the main difference between the structure and union. So remaining the working and the syntaxes and everything is same. Just replace the struct keyword with a union keyword. So in the keywords there is a keyword that is union. So in order to create a structure variable we have to use a struct keyword, and in order to create these union variables we have to use a union keyword. The remaining every syntax is similar. So the only difference is memory allocation for structure variable and memory allocation for union variable. So let us see the difference exactly in this session. So I will define one structure and one union so that we can see the difference between those two variables, structure variable and union variable. So for the structure, defining a structure, we have to use a struct keyword. So struct, write the tag name here. Struct student. So write down the variables. So let us write int r number and float percentage. So let us take only 2 and let us declare a structure variable by using struct keyword. Struct student s1 is a structure variable. Now let us define the union here. So union student, again I am declaring only 2 members of a union, that is one is roll number and percentage. The same r number float percentage, close the union. So here just I am replacing the struct keyword with union keyword, that is it. And for declaring the union variable, again you have to use the union keyword, union, the tag name, student and s1. So here s1 is a structure variable, here s1 is a union variable. So how to access the members of a union variable? So first of all, how to access the members of a structure variable? By using dot operator. Right? Here also we will use dot operator. So that means for accessing the roll number of a structure variable, we will use s1 dot r number, then s1 dot percentage. Here also same, s1 dot r number, s1 dot percentage. Right? But the only difference is here the s1 is a structure variable, here the s1 is a union variable. Now how the memory is allocated, how much memory is allocated for s1 and how much memory is allocated for union s1. So here in this structure the memory allocation is the total size of all the individual members of a structure. So for integer the memory occupied is 2 bytes. So if it is a 16-bit compiler, and for float it is 4 bytes. So the total memory occupied with this structure variable is 4 plus 2, that is 6 bytes. So for structure variable in this example, that means in this example for structure variable it will occupy 6 bytes of memory to store r number and percentage, because r number is declared with using integer which occupies 2 bytes of memory, and percentage is a float, is declared using a float data type which requires 4 bytes of memory. So the total size of structure variable, I mean the how memory occupied by the structure variable is equal to the total sizes occupied by the individual members of a structure. So 2 plus 4, it will be 6 bytes. So for here completely, so this is integer and this is float. So for this it is R number, it is percentage. So 4 bytes of memory and 2 bytes of memory. So total 6 bytes of memory will be allocated for this structure variable. Now in this union, first of all it will check for the individual sizes of, it will check for the sizes of individual data members. So for R number it occupies 2 bytes and for float percentage it occupies 4 bytes, right? So first it will check for the sizes of individual data members and it will consider the highest size, and that's the highest size will be shared between all the individual members. So here which one is the highest? 4 bytes. So the total memory occupied by this union variable is only 4 bytes. So only 4 bytes will be shared between R number and percentage. So first it will check for the size of individual members and it will select the highest size of individual member. So that highest size will be allocated and the same size will be shared between all the data members, right? So here it is a 4 bytes of memory. So this 4 bytes of memory will be shared between R number and percentage. So at a time only one value can be stored here. So because only 4 bytes of memory is occupied for all the union variables here in this example, so only at a time R number can be placed or percentage can be placed, but not both. But in this structure either both R number and percentage can be stored, because the complete size or complete memory allocated for this structure variable is total size of individual data members, I mean structure members. And here either R number or percentage, any one at a time can be stored here. So hope you have understood this one. First it will calculate the sizes of individual members and it will consider the maximum size of a individual member, and that maximum size will be allocated for the union variable, and that size will be shared, that memory will be shared between all the members of a union. So that is the only example, that is the only difference between the structures and unions. So here at a time we can read the roll number and percentage and we can write we can display the roll number and percentage on the screen. Here we can read R number and percentage, but at a time we can print only either R number or a percentage. That means only one member value can be printed on the screen at a time, right? So let us write a program for the union so that you can clearly understand here. So let us write here. So if S1 is equal to, open the braces, I am writing the direct initialization here. For the roll number it is 20, comma, percentage 75.6. Let us take this one. And here also, instead of taking the runtime initialization, let us take this S1 is equal to same. Let us write 20, comma, 85.3, or take the same thing, 75.6. Now let us print them on the screen. For printing we have to use printf R number is equal to percentage D slash T, percentage is equal to percentage F. So for this D, S1 dot R number, comma, S1 dot percentage. So for this printf, the output will be, so at a time we can read the two values and at a time we can print the value. So R number is equal to 20 and percentage is equal to 75.6. And here also same, for printing them, for accessing the members of a union, again we have to use a dot operator, right? So printf R number is equal to percentage D slash T and percentage is equal to percentage F. So for this S1 dot R number, comma, for this S1 dot percentage. Right? So here, what is the output? So as I have said that only one memory location will be considered, the highest memory location will be considered, and the same memory location will be shared among all the members of a union. So here, first R roll number is equal to percentage D. Here, wherever the memory is allocated here, first of all S1 is equal to 20. So first R number is equal to 20. Here 20 will be assigned here, and immediately after coming to this 75.6, this 20 will be replaced and 75.6 will be placed here. So the output will be R number is equal to null and percentage is equal to 75.6. So whatever the value we are recently assigned in the union variable, that value will be printed on the screen. So at a time only one value will be printed on the screen. So that will be the recent value which is assigned to the structure variable. So here first 20 is assigned to the roll number. So first 20 will be there, and immediately after assigning 75.6 to the percentage, that 20 will be replaced with 75.6 because the 4 bytes of memory is shared between roll number and percentage. And coming to here, both the memory occupied here is for both integer and float values. So that means the total size of the individual individual members. So here the 2 bytes of memory and 4 bytes of memory. So that means here the 20 value will be assigned and here 75.6 will be assigned. So whenever we are printing on the screen, both the values will be printed, and here only one value that is recently assigned to the union variable will be allocated. So this is the exact difference between the structure and union. So the only difference is memory allocation. So hope you understood this concept, the difference between the structure and union, and passing the structure to the functions, and every concept is same for the union also. Just replace the struct keyword with a union and we have to take care about this memory allocation, right? So hope you understood this concept. So let us stop here, and if you are having any doubts regarding the C language, feel free to post your doubts in the comment section so that I will definitely try to clarify your doubts. And if you like my videos, share my videos with your friends and subscribe to my channel for more video updates. Thanks for watching. Thank you very much.